we're going to talk about section 2.1 first. That's linear equations in one variable. Well, actually, this whole chapter is linear equations, but we'll start by saying that a linear equation in one variable is an equation that can be written in the standard form ax plus b equals c. And a, b, and c have to be real numbers. But a cannot be 0. Why can a not be 0? Well, what happens if a is 0? We have 0 times x plus b equals c. Well, 0 times anything is just 0, so we're left with b equals c. Well, that's good as long as b and c are the same number, but if they're not the same number, then that's nonsensical and we've completely lost our variable. So that's why a cannot be 0. So when we solve an equation, we perform a series of operations to the equation until the variable's isolated on one side of the equation, and the other side is a number, and if it happens to be a fraction, we need to make sure it's completely simplified. This brings us to the addition property of equality. So the addition property of equality says that the same expression can be added or subtracted to both sides of an equation without changing the solution of the equation. So I like to think of it this way. If I have a scale, y'all can make fun of my drawing if you want, I do all the time. Okay, if I add weight to that side, then this side goes up, correct? So I have to add the same thing, let's call it C. I have to add C to both sides of the scale in order for my balance to stay balanced. And I think of the equal sign as the middle of the balance. So for example, if we look at this first one, we have 2x plus 5 equals x minus 16. We need to get the x's on one side and the numbers on the other. So since I have a 2x here on the left and an x on the right, I'm going to subtract x from both sides of the equation. Now remember, it's like there's a 1 in front of both of these x's, even though we don't write it. So if we have 2x minus 1x, that gives us a 1x. And we haven't done anything with the numbers, so we still have plus 5. Now the x minus the x on the right-hand side canceled out, leaving us with a negative 16. Okay, the variable x is still not completely isolated because on the left-hand side it's got a 5 added to it. So in order to get rid of that 5, we need to subtract 5 from both sides of the equation, which then leaves us with x equals 16 minus 5 is a negative 21. So x is negative 21. We can always check this by plugging it back in for x in the equation and crunching numbers. So is 2 times negative 21 plus 5 equal to negative 21 minus 16? Is that true? Well, 2 times negative 21 is negative 42 plus 5. And is that negative 21 minus 16 gives us negative 37. Negative 42 plus 5 is indeed a negative 37. So yes, that checks out. Good. Now you don't always have to check. I just wanted to demonstrate that we could. And if you're concerned about whether or not your answer is correct, that might be a good idea. Now, at this point, you should pause the video and attempt to do number 2 on your own. I know it's probably a little scary because it has fractions, but remember the previous review sections we talked about how we do arithmetic with fractions. So go back and review that if you need to. Okay, so now that you've worked it out, hopefully on your own, and you've restarted the video, we have a -4/5 equals x minus 1/2. Well, the variable x is only on the right-hand side of the equation, so all we have to do is add 1/2 to both sides of the equation. When we do that, the -1/2 plus 1/2 cancel each other out, and we're left with x on the right-hand side, and we have -4/5 plus 1/2 on the left-hand side. Now, we have to find a common denominator, so we can go back and do our multiples. So multiples of 5. 5 times 1 is 5, 5 times 2 is 10, 5 times 3 is 15, 5 times 4 is 20. That's probably far enough. Now, multiples of 2. 2 times 1, sorry, is 2. 2 times 2 is 4. I can learn how to write here. 2 times 2 is 4. 2 times 3 is 6. 2 times 4 is 8. And 2 times 5 is 10. So you can see we have a 10 and a 10. It's the first number in both lists that is in both lists, so that's our common denominator. So -4/5. Okay, we need to change that into a 10 in the denominator, so we have to multiply by 2, which means we have to multiply the numerator by 2. Then we have plus 1/2, and we have to multiply the 2 by a 5 to get to a 10, which means we also have to multiply the numerator by 5. And that equals our variable x. So remember, when we multiply fractions, we multiply straight across. So 4 times 2 is -8/10, plus 1 times 5 is 5/10 equals x. And now we just combine our numerators. So -8 plus 5 is a -3/10. And that is our variable x. Okay, now you should pause and also attempt to do number 3 on your own, but let me give you a little hint. Sometimes we have to simplify before we can apply the addition property of equality. So here we should distribute the 6, and we should also combine any like terms that we have. So now you definitely should pause the video and try to do this on your own, and then restart it and see if you got it right. So, to check yourself, first we need to distribute this 6. So we have 5x plus 3 plus 2x equals 6x. 6 times x is 6x. And 6 times a -1 means we have -6. And then we still have that plus 9 tacked onto the end. Now let's combine like terms on both sides of the equation. So we have on the left-hand side a 5x and a 2x. So we can combine that, since they're added, 7x plus 3 equals, on the left-hand side, the -6 and the 9 are like terms. So we have 6x, and then negative 6 plus 9 is a positive 3. So now we subtract the 3 from both sides of the equation. And when we do that, the 3's on both sides of the equations cancel out and leave us with 7x equals 6x. Now I need to subtract the 6x to get it on the same side as the 7x. And so we have 7x minus 6x gives us a 1x, and 6x minus 6x gives us 0. So x is 0. So that concludes section 2.1. In the next video, we'll tackle section 2.2.